Imagine standing at the edge of the ocean. Feel the cold water pulling at your feet, the salt in the air, the sheer, impossible weight of it. Now ask yourself a question that most people never think to ask. Where did this come from? Because 4.5 billion years ago, and this water did not exist here. Travel back, not decades, not millennia, billions of years. The early solar system looks nothing like the calm, orderly neighborhood we inhabit today. It is a war zone. Everywhere you look, objects are colliding, crashing, melting, fusing, exploding. Planets are not born gently. A small, rocky world is beginning to take shape, the third planet from the sun. Right now, it is a vision of pure hell. Its entire surface is a magma ocean, liquid rock stretching thousands of kilometers deep, an atmosphere so thick with carbon dioxide and sulfur that it blots out the stars entirely. And yet, somehow, today, 71% of Earth's surface is covered in water. The Pacific Ocean alone contains more water than there are grains of sand on every beach on Earth. Scientists have spent decades chasing this question through ancient rocks, meteorites, and the farthest reaches of the solar system. For a long time, the leading theory seemed almost elegant in its simplicity: comets. Comets are ancient, icy wanderers, snowballs the size of mountains coated in frozen water. The logic felt obvious. Comets contain water ice. Comets crashed into early Earth. Therefore, comets delivered the oceans. Not even close. Scientists looked closer and found that the water inside comets and the water in Earth's oceans don't quite match. The ratio of deuterium to regular hydrogen in any sample of water acts like a chemical signature, a cosmic barcode. When researchers analyzed the water locked inside famous comets, Halley's Comet, Comet Hale-Bopp, they found something startling. The deuterium to hydrogen ratio in cometary water was almost twice as high as the ratio found in Earth's oceans. The signatures did not match. The trail had gone cold, and the mystery had just gotten exponentially deeper. Scientists turned their attention to a different class of space rock, asteroids, specifically carbonaceous chondrites. Carbonaceous chondrites are wet. They contain water locked inside clay minerals, hydrated silicates, chemically bonded to H2O at the molecular level. The deuterium to hydrogen ratio of water extracted from carbonaceous chondrite meteorites. It matched almost perfectly. Earth's oceans may have been delivered by asteroids, hammering the young planet during one of the most violent episodes in solar system history. Scientists call it the Late Heavy Bombardment. Roughly 4.1 to 3.8 billion years ago, something disturbed the outer solar system. Earth, Mars, the Moon, they were all pounded mercilessly. The lunar surface still bears the scars. Those ancient craters you can see with your naked eye on a clear night were gouged out during this catastrophic era. If the bombardment was that violent, how did any water survive the impact? The heat is enough to vaporize rock, let alone ice. Some of it did escape. Early Earth likely lost enormous amounts of volatile material to space during the bombardment era. Water locked chemically inside clay minerals was far more resilient to the violence. It was released gradually, incorporated into the growing crust. A slow, brutal, billion-year-long accumulation. One asteroid impact at a time, building an ocean drop by drop. The asteroids that delivered this water did not originate nearby. They formed beyond a gravitational boundary called the snow line. Something had to drag them across that boundary. That something was Jupiter. Jupiter, the giant, the destroyer, the planet that could swallow 1,000 Earths, may also be the planet that gave us the gift of water. Without Jupiter positioned precisely where it is, there might be no oceans. Without oceans, the rest of the story simply does not happen. Scientists began to find water in the absolute last place they expected, inside Earth itself. Deep inside, scientists began drilling into minerals called ringwoodite. And what they discovered stunned the geological world. The mantle holds 3 to 10 times more water than all of Earth's surface oceans combined. There is an ocean inside the Earth, invisible, silent, locked in stone, at pressures millions of times greater than the atmosphere above. A hidden reservoir that has been cycling water slowly to the surface through volcanic activity for billions of years. Earth's water had not one origin, but several. The oceans were assembled patiently, violently, across geological time from multiple sources. And then came the rain. The first rain in Earth's history. Imagine standing on the surface of a cooling Earth, perhaps 4.4 billion years ago. The sky overhead is a bruised purple and sulfurous orange. A planetary rainfall so intense and sustained that it carved the first ocean basins, flooded the first valleys. The oceans, once formed, did not empty. Earth's gravity held them, and the water cycle began its endless, life-sustaining rotation. Ancient zircon crystals, the oldest minerals ever found on Earth, dated to 4.4 billion years ago, carry chemical signatures suggesting liquid water was already present. Within 100 million years of Earth's formation, liquid water was already pooling on its surface. The first evidence of microbial life appears in the fossil record, almost as if the moment the conditions were right, life erupted, as though water was not merely the environment for life, but the trigger. The water in your body, in every cell, every drop of blood, every tear, was forged in the destruction of ancient asteroids. It drifted through the void of interplanetary space. It survived catastrophic impact. It was exhaled through volcanic vents. It fell as rain on a world still learning what it was. Japan's Hayabusa 2 mission returned pristine samples from asteroid Ryugu. Studies of meteorites arriving today, ancient travelers unchanged since the birth of the planets. Earth's water is ancient beyond comprehension. It predates the planet itself. The hydrogen in your oceans was forged inside dying stars. The oxygen was created in stellar explosions that scattered their contents across the galaxy. They found each other in the cold reaches of a young solar system, bonded together, froze onto rocks and dust and drifting asteroids. Through gravity, collision, catastrophe, volcanic breath, and billions of years of patient time, made it here, to this blue world, to these shores, to you. If it took all of that, how many other worlds, circling how many other suns, across how many other galaxies, ever got lucky enough to have the water find them too?